Hello and welcome back. In this lecture I want to go through a demonstration of how you can use the debugger in the CodeBlocks IDE. So I want to run through the graphical user interface, show you how you can start up a program in debugging mode, how you can set breakpoints, how you can look at the call stack, and how you can view different variables using the watch window. So I have CodeBlocks up right now with just a simple program that's determining an average. I'm going to use this as my demonstration. All it does is it reads in 3 integers and stores them and then computes their average. But before we get to any of that, I first want to go over a couple basic things. If you want your project to be able to debug your project, you need to make sure that you have correct settings when you build your project. So the first thing you need to do is you need to go to your settings and go to your compiler. Inside here are all the options that you can provide when you build. And depending on what compiler you have selected, you want to make sure that's selected, and you want to select the compiler settings tab. And then under the compiler flags, you want to make sure that you produce debugging symbols. So you want to make sure that under debugging, you have this checked for -G. That needs to be checked so it produces debugging symbols so that when you build your project, you can actually view certain code. So there's 2 ways to build your project. You can build it in release mode, which means that it has no debugging symbols, and that's what you do when you want to release your program. The program tends to be smaller as well. When you're in development mode, you typically want to build for debugging so that you can use the debugger. The executable tends to be larger because it has more information in it. So you want to make sure you produce debugging symbols with the -G option. And you'll probably also want to enable all common compiler warnings. Those are the 2 options that you need to have on for debugging. Now, you also want to make sure that none of the other settings are doing any optimization switches for removing any symbols or anything like that. Sometimes there's a -S option that's used. You want to make sure the -S option is not enabled. By default, nothing is really enabled, so you should be good to go. But none of these optimization checks should be checked. Because, especially this one, strip all symbols from the binaries, -S, make sure that is off. That cannot be on. Once you have all this set up, you want to click OK, and you're pretty much ready to go to start debugging your code. The way that you debug your code is you can start your program in debugging mode. So you still want to build it like normal, do a normal build, and that will compile and add your debugging information. Then when you want to run it in the debugger, you just say start continue. Now if you don't have any breakpoints set, the program's going to run just like normal and you wouldn't see anything. So now I want to talk about breakpoints. Breakpoints are a way to stop your program at a particular statement so that you can look at the value of variables, and also, if you want to, step line by line to see what's going on with each statement and its logic. If you don't set any breakpoints, your program's never going to stop, so you're not going to be able to view any variables. You're not going to be able to look at the call stack. So if I just run this and I say start continue, it's going to run like any other program. You know, this is getting the average of 3 numbers. Now, I don't have any breakpoints set, so it basically just returned. You didn't even see the print statement here. It just basically returned completely. The debugger finished with status 0. Everything was fine. If you run it in normal mode, then you can actually see the output. So the program should calculate the mean of 3 numbers that you enter, in this case 987, which is the mean is 8. But in debugging mode, it just simply returns if you don't have any breakpoints. So you want to set a breakpoint when you're trying to debug your program using the CodeBlocks debugger. Again, it's just a simple debug menu option at the top to start it. And then you can actually, if you don't have a breakpoint, you could say run to cursor. And this will set a breakpoint wherever your cursor is. But again, breakpoints are a way to stop the program so that you can either run through it line by line or look at the values of variables. You also notice up in the toolbar there are other debugging options. Right here, you can start debugging by hitting the play button, the red play button. And then there's things that you can run to cursor by hitting this menu toolbar option, I should say. And then once you're in a breakpoint, you can use these to step out, step over the line, and so forth. So when you say step out, you're stepping out of a function. If you're inside of a function, you'll step right out of it. If you say step into, you'll step into a function. So if you have a breakpoint with printf, you'd actually go inside the printf function. If you say next instruction, you're going to go to the next line of code. And this is usually the most common. You can also step into instructions as well if there's any nested or functions inside of a function. But these are the main options. You can also access these options up in the menu option as well, and they also have shortcuts for the keyboard. And those are the main ones. Now, the debugging windows are also important, which I'm going to show you how to access. The main ones that I use are the call stack and the watches. But you can also look at the memory that's being allocated and deallocated. You can look at any additional threads. Threads are separate execution points in a program. You can look at the CPU registers, and you can look at the breakpoints that you have set if you have any set. The easiest way to set a breakpoint in your program is to just go to the left-hand side of the code and click it and you'll see a red circle that's added. That means that a breakpoint is set. And so when I run this program in debug, it's going to run until it sees a breakpoint. It's going to stop. And that's a breakpoint right there. And I put it on the first line of code. So now when I debug and I say start continue, it's going to stop the code right at that. It actually stops at line 10 because this is a declaration. I have a couple windows that I already brought up, but when you notice if you go to the code, nothing's happened yet because it hasn't even asked the user to enter information. Now if I step one line over, right, like this, or that was the next instruction, you see it goes back here. If I go to the next instruction, it goes to line 11. And if I go back to my code, you'll see that it printed out the enter. Now if I say next instruction, it's going to try to read in some information. It'll try to read in the first information, which you might have to actually hit it 3 times because it's waiting for input. So typically what you'll do is want to put a breakpoint on the next line and just hit the play button to continue. The play button will stop at the next breakpoint. Now since it's asking for information, I entered 6. I want to enter 8, 7, whatever. Now it gets to the next line and it's going to print it. So here I could say step over again and it's going to go into another function. So I could say step out. But it may take a number of executions till it actually prints out the data. So again, another easy way to do it is just add another breakpoint and hit the play button. And it will go there, and then you can go back to your program and you can see that it printed out the data. So it's very useful to be able to step line by line to help figure out what's going on. Now as you're stepping through, and let's actually just hit the play button to end. That the program is done now. And let's put a breakpoint, instead of in the main, let's put a breakpoint in the average function. Now let's debug and say start continue. Now when we debug, we can enter the information, and it hasn't got to the average yet, so I'm just going to enter 3 numbers in. And now it actually called the average function. And this is where you can start using the call stack and the watches. There's no point in using the call stack if you're not inside of a function or functions have been invoked. To get to the different windows for debugging, you can go to, like I mentioned, right here, debugging windows on the toolbar, or you can go to debug and you can go to debugging windows here. Now I currently have 2 windows up, the call stack and the watches. I drag the call stack and the watches down to this view so I can see it while I'm debugging and stepping through. But the call stack is on the left hand side. This is the call stack. And the call stack says that the call stack is where you can see the different order of functions being invoked. You'll see on line 1 the main function was invoked. It goes from the bottom to the top. So main was invoked on line 13 right here, and that called the average function. The average function was invoked after that, and it actually displays the parameters that were sent, the arguments that were sent, 7, 66, and 55. And so then it actually goes to line 28 because that's where it was invoked. And as you're, so that shows you the call stack, and you can double click on it to go to different, if you have multiple source files, it will take you to that source file and so forth. The other really important window is this watches window. It displays all the variables in your program and the data. So right now we have sum is equal to 7.567 322. If I step over, we can see the value of variables changing. So if I step over and go to the next instruction, we're now on line 29, and you saw that sum changed. Sum is now 128, right? And we can keep executing over that. Sometimes you have to hit it multiple times to go to the next statement because it does multiple iterations. So this is a simple program that's very easy to use the debugger. You'll see, you notice how easy it is. And the main things you want to focus on is the breakpoints, the watches, and the call stack. That's what I typically use, but you can definitely play around with other ones. There's also menu options and keyboard shortcuts to the different stepping over and stepping inside functions, right? So the other thing, if you step in, so let's just end this program. If I put a breakpoint on the printf and I debug and start there, it's going to ask me for my numbers, and then it's going to stop at the printf. Now if you do a step in, that should go in the printf function or the average function. So now it goes into the average function. If you did a step over, it would go through each statement, and eventually you wouldn't go in there to see anything. But here again, you can see the values of the variables that will change, and you can see the call stack. Now with a program that has many functions and so forth, the call stack can get much larger than this. The only other thing that may be important is the breakpoints. If you want to see what breakpoints you set, it will show you all the breakpoints in your entire program, where they're located. In this case, main.c on line 13. But you'll have to play around with this, get familiar with it, get comfortable with it, and use it quite often for problems that you can't figure out with basic debugging techniques. Or if programs crash, go line by line, and as you go line by line, you can actually see the program exit once it crashes, and you would know what line that occurred on. Again, this is a small program, but you should get the basic understanding of how debugging works. Again, I hope this was helpful. The best way to learn this stuff is to start playing around with it and start using it. Bring up one of the programs that you worked on in your previous challenge, add a breakpoint. Very simple. Just click right inside the thing to add breakpoints. Start it up in debug mode and step through each line and see how the variables change and how the call stack increases if you have bigger functions. Thank you.